Hi, hello everyone. Last lecture we have covered the basics and as well as the syllabus discussion as per the iScheme MSBT. Today we are going to see some of the very interesting topic, that is a direct and bending stress. So we have last lecture we have covered the structure, that is what you understand with the structure, what are the types of various of the structure, and where the bone the your TOS, that is the theory of structure, we already covered. So those who are not seen that video, you have to watch that earlier video, that is a basic and syllabus discussion. And we have already covered that what are the weightages of the marks as per an MSBT syllabus and what are the list of the topics we have covered. So this type of the covered earlier videos, please watch that. And those who are not watching that video, you can go through the YouTube also. We have uploaded that video, so you will enjoy that session. Okay, sure. Let's start the further. Ah, Last lecture we have missed the one, this graph. Why we prefer the shears class notes and as well as the clear shears classes. So my dear students, please see that MSBT paper, all the branches paper analysis have done here for you. So why we prefer the class and as well as the notes. You can see this graph here around 95, okay, 95 to 100%. This is from the shear class notes as well as the shears, whatever the teaching methodology will be there. So we have a number of the branches around the all 5 branches will be with us. So we have done various paper each and every bit. Okay, whatever they are asked in the examination we have to take and we have to make a plot a graph. So you can see the winter 22 to summer 2019. So this data with us, so we have plot the graph. Basically we have go through the each and every paper and we have decided the this data. Okay, so my dear students, you can see the just 2022 winter we have for the first year students 99% around the from the shear class notes, and similarly you can see the from the second year for the 98%, and third year students we have to got for the 100%, because the third year is also is most important according to that various years. So my dear students, so please trust the shears class notes as well as the shear classes. Don't waste the classes, my dear students. Now this is the most important slide for you. Okay, now if any course purchase you want, you can download the app now. So you will get diploma recorded as well as the live classes to you. So this is available on the Play Store. You can download, like type just in the Play Store shears, right? So this apostrophe you can don't miss, please. So this is the shears and this is the logo, and download the app now and share to your particular friends. My dear students, today we are going to see, after the basic details, we have to, without wasting much time, we have to start the chapter number 1, that is the direct as well as the bending stresses. Right? This is the huge marks weightage will be there. 14 marks weightage will be there from the. This generally asked in the question number 1, 2, and 3. Okay. So माझ्या स्टुडंटनो थोडंसं क्लास चालू असताना व्हेरी अटेन्शनने ऐका, बिकॉज यू हॅव टू ऑनलाईन इट सेल्फ, अँड ऑनलाईन मध्ये मी अतिशय वेगळ्या पद्धतीने मी तुम्हाला शिकवण्याचा प्रयत्न करेन अँड सगळे कॉन्सेप्ट म्हणजे क्लिअर करण्याचा पण प्रयत्न करेन. ओके, सो डोंट वेस्ट for scrolling down etc. You will focusing on the lecture and you have to use the headphone that will be benefit for you. Okay, so my dear students, the important points before starting the lecture. Okay, so this will be around the 80%, 80 to 85% problems will be comes in examination. 30% will be around the 10 to 15% weightage will be there about the 70 marks paper, right? So you have to must be remember, please make a formula short notebook with you. Whatever I will teach from here onwards, you will make a on that day formula short notebook. This will be most important. I will tell all the students. I will request it to all, you have to make a formula short notebook. Then types. From here onwards, in the MOS, we have not seen the various type 1, type 2 problem, but here we have covered the type 1, type 2 problem. These are the some standardized problems will be there. You have to must be follow that step. You will be easily remember that step in the examination also. So that's why you have to also add that various types in the particular the short notebook itself. And you have to make a practice whatever have taken the sessions to you. So at least you have to make that in once in a week you have to practice. Suppose you have to done the classes from the Saturday to Saturday, or you can say the Monday to Saturday. You have to practice that is in a once a week. You have to decide your itself, and it will be benefit for your end of the course. Okay, so please focus it. This important attentions is there. Now, my dear students, we are going to start the today the basic topic, that is the introduction part, and then after that we have to see these various content in the direct as well as the bending stresses. My dear students, please use the headphone so back for the better understanding purpose. Now, my dear students, आपको एग्जामिनेशन जब जब आएगा तब ऐसा चिड़चिड़ापन होता रहेगा, राइट? किसकी वजह से होता रहेगा इसको चिड़चिड़ापन? सबको अभी आप लर्निंग स्टेज पे हो, जब एग्जामिनेशन पे जाते हो तब आपको स्ट्रेस आता रहेगा. ओके, सब बैकलॉग पड़े, ये हो गया, सो एग्जाम की स्टडी नहीं हुई और एग्जाम आया तो भी आपको थोड़ा सा खुद तो मन में हलचल होता रहेगा. सो दैट विल बी कम्स टू द एग्जामिनेशन स्लोट्स. बुक्स देखने के बाद आपको सबको टेंशन आता रहेगा, ये यार कैसा पढ़ने का, कैसा कौन सा टेस्ट में एग्जाम में और टेस्ट में कौन सा पेपर पैटर्न बनता है, एक्सेट्रा एक्सेट्रा. सो बिकॉज ऑफ द लोड, राइट, विच लोड इज देयर, दैट इज द लोड ऑन द एग्जामिनेशन. दैट इज अ बुक्स देख के भी आपको मन को थोड़ा सा घबराहट होता रहेगा. वो घबराहट कहाँ पे हो रहा है, तो मन के अंदर हो रहा है, राइट. सो इसकी वजह से आपको आप शो कर रहे हैं कि चिड़चिड़ा हो रहे हैं, गिलगिलाहट हो रहे हो. सो ये कैसा रोक सकते हैं? ये मैं हूँ, सो इसलिए टेंशन मत लो, मैं आपको रोक सकता हूँ. So basically you can see this is the books will be there. So because of the examination, so you will be having the tension, right? So because of that there is a stresses will be developed, right? Where the stresses will be developed? The stresses will be developed, my dear students, into your internally. So that's why this chichidapan will be comes. So exactly, my dear students, in the structure also the external load will be acting on the structure, right? So load that is externally will be acted. जैसा एग्जामिनेशन था वैसा हो एक्सटर्नली हो गया ना एग्जाम. अभी एग्जाम होने के बाद देखो आपकी तसल्ली पूरी होती है, आप मुस्कुराते रहते हो, तो बट लोड आने के बाद आप थोड़ा सा गिलगिलाते हो. So that will be having your body same like that is a cross sectional पे act होता है. What is the cross sectional exactly? The cross sectional, suppose you have to take one here, this having the cross section and you have to cut it from that, right? This is a circular section we will showing. So this is nothing but the cross sectional area. So external load आया है, किसके ऊपर एक्ट होने वाला है? क्रॉस सेक्शनल पे एक्ट होने वाला है. तो इसकी वजह से जब तक आपको लोड divided by the cross sectional area hoga, so that term is called as a stress. The stress is nothing but the internal resistance offered by the body against deformation is called as a stress. You can mathematically say that the stress is nothing but the cross sectional per unit area also, right? So the sigma is the Greek letter. Okay, so sigma is equal to sigma is equal to stress is equal to load upon cross sectional area. You can say the mathematically the stress, the SI unit का system आपको पता ही रहेगा, न्यूटन पर mm square, or you can say the mega pascal. So my dear students, there are the n number of the unit of the stresses will be there. So you can see the Newton per meter square को अपन पास्कल भी कहलाते हो. वैसा 1 kPa that is the किलो पास्कल के लिए आप 10⁻³ लिखते हो न्यूटन पर मीटर स्क्वायर में. Then 1 मेगा पास्कल 10⁻⁶ पास्कल लिखते हो. जैसा 1 मेगा पास्कल is nothing but the 1 न्यूटन पर mm स्क्वायर. मैं बताता हूँ ऑलरेडी. सो 1 मेगा पास्कल दैट इज द माजलेला बोलता हूं मैं. माजलेले को दान करते हैं क्या? नहीं दान करते भाई, 1 रुपए भी दान नहीं करने का. जैसा उतना है उतना ही माजलेले को मस्ती रहता है, इसकी वजह से m stand for the mass ले ला. So you can remember like that also. You can MPa is nothing but the megapascal. That is a 1 MPa is equal to 1 Newton per mm square. So 1 gigapascal. Okay, 1 gigapascal गरीब आला आपण दान करतो. किती दान करतो? 10 raised to 3 Newton per mm square. Huh? So but 1 GPa is equal to 10 raised to 9 megapascal is not. That is a 10 raised to 9 pascal. Please clear yourself. This is that 1 gigapascal is nothing but the 10 raised to 9 Pa, that is the pascal, but 1 gigapascal is equal to 10 raised to 3 Newton per mm square. I will cover all these things again in the problem point of view. Okay, जब problem अपन start करते हैं तब आपको पूरा फिर से एक how to convert this unit. So in this particular session we will cover the theoretical part, and problem point of view we will cover the all the basic conversions of the particular these stresses. Okay, now what are the nature of the stresses? These are the basics. So compression stress. Okay, this is the compression, you can say dabana. Okay, ऊपर से ले लो दबाव. So this will be having the compression. Tension, you have to make a tension. Okay, then after that the shear stress. The shear is nothing but the you have to make a like shear, equal and opposite forces you have to apply, so that the shear will be developed. Then torsion, that will be having the shaft पे torsion होता है, right? Okay, जब कपड़े धोते हो ना तभी भी torsion होता है क्या नहीं? Okay, bending, so that will be having the bend. You have to make a after the application of the load, so there is the bending should be developed. So that is the bending stresses will be developed. These are the various nature of the stresses will be there. You already studied in the MOS itself. Okay, see, you can see this will be having a practical related example, or you can see the applications will be there. That is the compression one. You have to take a spring, so this will be compressed. This will be having the torsion. You have to make a कपड़ा जब धोते हो तब you can say from each end you have to make a twist, right? And then after that you have to remove that water from the your whatever the moisture will be there, you can say the remove from the water from this because of the twisting, and then upon वाळवतो. So that will be the concept here. Then tension will be developed, you can see. So this in the string there is the tension will be developed, and this the bending. Okay, आप सलाई ले लो, सलाई लेके क्या करो, उसको बेंड करो. Okay, under compression होगा, ऊपर tension आ जाएगा. So this will be bending, and this will be the shear stress with the help of the bolt you have to connect it. So maybe fail this is single shear, your and double shear may be there. Okay, so this will be having the regarding the your concept of the nature of the stresses. Now my dear student, this is the most important bit we are going to cover now. Please focus on the lecture. Concept is the most important things in for increasing your knowledge, right? So my dear students, you can see this is column is there. That is the, suppose you have to say the column. When we say the column is having the vertical member, having always having the transverse loading on it, that's a compression. So that is nothing but the column. Suppose you have to take a in a plan. So these are the two axis, that is the, this is called as a x-axis. My dear students, please see this. This is called as a x-axis, and this is called as a y-axis. Okay, this is called as a plan. Now this is in the 3D view I'm representing here. So this is called as a here again x-axis. Okay, and this is called as a, sorry, just rearrange that terminology. This is the x-axis, okay, and this is the y-axis. So similarly we can see we have to apply the load on each faces, that is the act as the CG पे लोड एक्ट हो रहा है. यहाँ पे देखो CG पे ही लोड एक्ट हो रहा है, यहाँ पे भी CG पे लोड एक्ट हो रहा है. This is the elevation point of view. So okay, so exactly what is the concept is there. So the direct load will be developed. How the direct load is arises here, when the load will be always acts that externally. So ये क्या कह रहा है, direct load. So how will you define this direct load? When the line of action coincide with the axis of the member is called as a direct load. What the when the load act on its CG is called as a direct load. Direct load पे CG पे act हो रहा है, so that is called as a direct load, and it is also called as a axial load also. That is we generally denoted as a P, you can say. Okay, so then again we have to take one similar column here. Okay, that is in plan. We are showing the x-axis as well as the y-axis, and similarly 3D view. Just we have to apply here, my dear student, away from the axis. So whatever the load will be there, now the load will be shifted from the CG to some distance. So that some distance is called as a eccentricity. Okay, that load is called as a eccentrically load. So my dear, please concept the two terminologies here. The first one is having the direct load is having here CG, and the second one is having the eccentric load. The eccentric load is nothing but the away from the axis it acts. This is called as a eccentrically, or you can say the eccentric load. The eccentric load is nothing but the when the load does not coincide with the axis of the member is called as a eccentric load, and the eccentricity is nothing but the distance between the axis of the member or to the distance of the where the exact load will be act. So that portion or that distance is called as a eccentrically. Please clear this concept. These two concept is the most important. Eccentric load को क्या सिंपल वे से तरीके से बता रहा हूँ, जो लोड है जहाँ पे एक्ट हो रहा है उस डिस्टेंस से जहाँ पे your CG act हो रहा है, this distance is nothing but the eccentricity. And eccentric load away from the axis, the load is coincide with the axis of does not coincide with the axis of the member. Please, axial load coincide with the axis of the member, and this will be having the does not coincide with the axis of the member is called as a your simply eccentric load and as well as the eccentricity. Clear everyone, all of you? So now we'll move further slides. See, in examination, how they can ask. Examination में कैसा पूछा है? So that will be going to see here. So define axial load. So define direct load with the example. Define eccentric load with the example. Define with neat sketch axial load and the eccentric load. 2 mark का क्वेश्चन आ सकता है एग्जामिनेशन पे. You can write easily like that. When the line of action coincide with the axis of the member or its CG is example load on the column. So my dear students, you can see this is the load plan and this is the elevation. You can draw the diagram like this. You will get the 2 marks easily in the examination. Eccentric load, already I have told to you that a load acts away from its centroid or the load whose does not coincide with the axis of the member is called as a eccentric load. You can draw this sketch easily. Okay, this is the plan and examples: load on the bracket, wind pressure on the walls as well as the chimney. You can see the eccentricity. 2 mark के लिए क्वेश्चन पढ़ा था and write down the practical examination with the help of this. Then the 4 marks will be asked in the particular this way. Define eccentricity and write down the practical examination. Eccentricity is nothing but the when the load acts away from the axis to the distance, whatever the distance will be there. So that is nothing but the eccentricity. Or you can say that distance between the axis of the member and the point of the loading is called as a eccentricity. The eccentricity generally denoted as a small e. Okay, so practical example, these are the wind pressure on the walls and chimney, water pressure in the dams and retaining walls, so load on the bracket, load on the exacted C clamps and by the screw. Just generally we have to use mechanical students will be use this one, right? And civil engineering will be it having the steel structure, and civil engineering having is in the dams as well, a retaining wall and the chimneys will be there, right? जो झाड़ पे बैठता है वो चिमनी नहीं नहीं यार, दिस चिमनी इज अलग है. जो स्मोक जो धूल रहता है ना, जब जलने के बाद धूल ऊपर जाती है इंडस्ट्रियल एरिया में, वो चिमनी वो सिविल इंजीनियर डिजाइन करता है. दैट इज लाइक स्ट्रक्चरल इंजीनियर, right? So my dear students, you can see this is the arrangement of the eccentrically loaded. You can see this is eccentric loaded. This load will be developed, the movement will be created here. Okay, so ये जो load है एक column जो बता रहा है with the help of the connection of the gusset plate as well as the bolted. So ये बंदा लेने वाला है, right? So this will be having the wind pressure. So you can see the plan. So this is the having the examples of the your eccentrically loaded. Clear everyone? My dear students, this is the from the review from got Concept Engineering Academy and Research, source from the Google, 4.9 rating out of the 5. So you can, for trust purpose I will show it to you. So you can go to the site, you have to search Concept Engineering Academy and Research. You will get the all the reviews to you given by the students, right? So you can clear all your doubts here itself. Now my dear students, we will move for the next bit, that is the direct stress. When the direct stresses will be produced. We have already seen that the direct load. So because of the direct load, the direct stresses will be developed when the applied forces acts perpendicular to the cross section on its centroid. Only direct stresses will be developed, right? The direct stress is generally denoted as a sigma O, or you can say the sigma D. This will be provided uniform in nature throughout the compression. Okay, so the direct stresses we generally denoted as a sigma 0 P divided by area. This is the first formula you will note in the short books. Direct stress is nothing but sigma 0 is equal to P by area, so that is the Newton per mm square. P is nothing but the external force or load, A is nothing but the cross sectional area, that is in mm square. Examination में पूछा था define direct stress, okay, or explain the direct stress. You can write down this much, that is the sufficient. Direct stress कैसे produce होता है? That will be because of the direct load, and when the applied force act is the perpendicular to this cross section. Only direct stresses uniform in nature throughout the cross section. My dear students, now we'll move further things, that is the bending stresses. How will you develop the bending stresses? That will be because of the bending moment. That will be having the bending moment is nothing but we have the eccentrically जब कुछ आएगा, eccentrically load जब act होगा structure पे, so that time there is the movement should be developed. So because of that movement, you have to provide the direct as well as the bending stresses will be developed. So that nature will be having the compression partially and partially compression and partially tension will be developed. Clear everyone? So this is the regarding the bending stresses. Now how will you create the formula? You already studied in the MOS, that is the flexural equation you have studied, right? So what is the flexural equation? Oh, we have remembered the technique, the formula. We already launched some courses will be there. Formula remembering technique. You can watch that. You will enjoy all the formula remembering technique. From that formula remembering technique, I have use this formula like this. May I follow you, Elizabeth Rani. So from this equation, this is nothing but the m upon I, f upon y is equal to e upon r. फॉर्मूला रिमेम्बरिंग टेक्निक के लिए मैंने ऑलरेडी ऐप पे वीडियोस डाले हैं. You can go to that videos. You will enjoy the session, that one. So because the formula remembering technique is the most important, and these formulas will be we have to using in the further coming examinations also. So that must be you have to get. Okay, so this formula you have to use like sigma b. Just rearrange this f is nothing but the sigma. In the is code we have to use notation f. Okay, so the f is nothing but the sigma b, that is the maximum bending stresses. So just rearrange the formula m upon I into y. So this is nothing but the sigma b is there. The SI unit of the sigma b is Newton per mm square. So m is nothing but the p into e, that is the bending moment, that is in the Newton mm, and the I is nothing but the moment of inertia, that is in mm raised to 4, and y is nothing but the distance of the neutral axis from the layer, that is in mm. You can rearrange this formula like this: m upon z. Z is nothing but the strength. Z is nothing but the strength of the section or sectional modulus. I divided by y, moment of inertia to the distance of the neutral axis from the fiber. So I upon y is nothing but the z. That is, you can write down this formula also: sigma b is equal to m by z. Okay, clear everyone, my dear students? Please note down these formulas in the short notebook, so you will enjoy the at the end. So that's why just focus on the lecture, and as well as the just carefully write down the formulas in the your short notebook itself. Okay, now we'll move further. What are the resultant or intensity of the stresses? Just make an addition or subtraction. That is, sigma max is nothing but the simply maximum stresses is equal to sigma 0 plus sigma b. Just you have to use the plus sign. Okay, sigma 0 is nothing but the p by a, sigma b is nothing but the m upon I into y, or m by z. Minimum stresses is equal to sigma minimum is equal to sigma 0 minus sigma b. So this will be having the notation minus. So what are the units? This one same like that, Newton per mm square or megapascal itself. Okay, so these are the various cross section will be there. You have to please note down in your short notebook, so you will enjoy this session. Okay, I hope so. You already covered this in the MOS. Rectangular, you know very well, b into d, square b square, solid circular pi by 4 d square, and the hollow circular section pi by 4 capital D square minus small d square. That is the capital D is nothing but the Amitabh Bachchan and Jaya Bachchan. Capital D is nothing but the Amitabh Bachchan's square minus small, that is the Jaya Bachchan square. So please remember, my dear students, this formula is the most important, will be there in your upcoming examination also. Okay, so I will provide to you some moment of inertia formulas also. So it is in the next lecture we will cover the formulas from the moment of inertia, as well as the we will going to see the some various kind of the problems. So you will enjoy this session. Okay, so just download the app and from the shares itself. Okay, it is on the Play Store. You will enjoy the your diploma recorded, as well as the live classes will be there. So my dear students, you have to share this app for your student benefit point of view. So we will design the courses various streams, like low level to high level problems you are covered, and you will enjoy this session. So thank you so much.